Hello everyone. Let's continue our chapter motion along a straight line, that is 1D motion, one dimensional motion. So in the previous lecture we discussed about differentiation in calculus. So how to calculate velocity when position is given and how to calculate acceleration when velocity is given. So we have discussed about v is equal to dx by dt and a is equal to dv by dt. So let's discuss some critical questions, some important questions related to these two formula. How to find instantaneous velocity and how to find instantaneous acceleration. Suppose x is given as t cube, so v will be dx by dt, so it will be 3 into t square, because when x is equal to t raised to n, so dx by dt is equal to n t raised to n minus 1. So this is the basic example of differentiation. Similarly, if v is given as t cube, so we can find acceleration as dv by dt, so that is instantaneous acceleration, so it will be 3t square. So this is the acceleration at time t, at time t, and this is the velocity at time t. So suppose at 2 seconds they are asking, so we can put t is equal to 2 here. They are asking what is acceleration at 2 seconds, so we can put t is equal to 2 here. So these are two examples in which when x is given as function of time, how to find velocity, v is given as function of time, how to find acceleration. Now we have formula for acceleration, dv by dt. So we can use this formula when v t relation is given. When vt relation is given, what if vx relation is given? Then we can use the formula a is equal to dv by dt. Same formula we can use, but we have to modify it. We will multiply and divide by dx. Same formula, little bit we are modifying it. So dx. Now this dx will come here and this dv will come here. So we can say dx by dt is equal to dv by dx. Now dx by dt is instantaneous velocity v. So v into dv by dx. So acceleration is equal to v dv by dx, means you find instantaneous velocity v, then multiply it with dv by dx. Let's take one example. If v is equal to x cube, then how to find acceleration? So acceleration will be v into dv by dx. So that will be x cube into dv by dx. How to calculate dv by dx? We will use the differentiation formula. So dv by dx will be 3 into x square. So substitute this 3 into x square. So we have 3x raised to 5. Acceleration will be 3x raised to 5. Let's take one more example. Suppose we are given v is equal to x square plus x, and the question is asking find acceleration when particle is at x is equal to 2 meter. Suppose the value of x is given. The particle is moving along x axis, that is our straight line, and we can say it is motion in 1D. So when the particle position is 2 meter, what is its instantaneous acceleration? Because whenever we have this at in a question, that means it is instantaneous. So sometimes time will be given, maybe t is equal to 2 seconds. Sometimes position will be given at x is equal to 2 meter. What is the acceleration? So this is instantaneous acceleration, but we cannot use dv by dt. We cannot use this formula here. We have to use a is equal to v into dx by dt. We cannot use a is equal to dv by dt. We have to use a is equal to v dv by dx. So a is equal to v, which is x square plus x, then dv by dx. Now we will find dv by dx. So v is equal to x square plus x. So we have dv by dx is equal to, now separately we have to differentiate this. So x square, when you differentiate, it will be 2x. When you differentiate x, it will become 1. So dv by dx is equal to 2x plus 1. Now put it here, dv by dx. So we have acceleration is equal to x square plus x, because v we have to substitute, then dv by dx, which is 2x plus 1. So this is the instantaneous acceleration. Now we will substitute x is equal to 2 here. 2 square plus 2 multiply by 2 into 2 plus 1. So that will be 4 plus 2 multiply by 4 plus 1. So that is equal to 6 into 5. So answer is 30. So final answer is 30 meter per second square. That is our answer. Next, suppose x is given as t square plus t and velocity is asked. So we can find v is equal to dx by dt. So we will differentiate this. This will be 2t plus 1. And suppose acceleration is also asking. So we will use a is equal to dv by dt. So that will be equal to differentiation of 2t, which is 2, and differentiation of constant 1, which is 0. Differentiation of constant is 0. So acceleration is 2. Why I am giving this question? Now slightly I will change this. Instead of x is equal to t square plus t, I am writing t is equal to x square plus x. And what is the question? I am asking velocity and acceleration. Find velocity and acceleration when x is equal to, say, 2 meter. At x is equal to 2 meter, what is velocity and acceleration? Now what is different in this question? In this question, it is x is equal to t square plus t. Here t is equal to x square plus x. So instead of finding dx by dt, we will find dt by dx. So this is one of the trick to solve this type of question. As we are aware, many problems can be solved by using perfect trick which is applicable to that particular type of problem. So it is a trick. So instead of dx by dt, I am finding dt by dx. So we have t is equal to x square plus x. So when you differentiate x square with respect to x, so that will become 2x. When you differentiate x with respect to x, it will become 1. Now dt by dx is 1 by v, because we know that dx by dt is v. So dt by dx will be 1 by v. So it is 1 by v is equal to 2x plus 1. So we can write it as v raised to minus 1 is equal to 2x plus 1. So basically we got our answer. One of the answer we got. 1 by v is 2x plus 1. So that means v is equal to 1 by 2x plus 1. So if we substitute x value, which is given in question as 2 meter, so we'll get v is equal to 1 upon 2 into 2 plus 1. So that is 1 upon 4 plus 1. So that is 1 by 5 and that is 0.2 meter per second. This is velocity at x is equal to 2 meter. Now how to find acceleration? So for finding acceleration, we are solving further. So now we have 1 by v is equal to 2x plus 1. So v inverse is equal to 2x plus 1. Now let's differentiate with respect to time. Differentiate. So this is again another trick. So two tricks we are using in this particular question. So differentiate with respect to t. So we will use d by dt of v raised to minus 1 is equal to d by dt of 2x plus 1. Here the function has v. In the bracket we have v, but we are differentiating with respect to t. So we will use chain rule here. So d by dv of v raised to minus 1 into dv by dt. So we are multiplying and dividing by dv. So the term will be unchanged. Without changing the term, we are multiplying and dividing by dv. Now on the right side we get d by dt of 2x plus d by dt of 1. Now we will use the differentiation formula here. So whenever you have d by dv of v raised to n, so it will be n v raised to n minus 1. So this will be minus 1 into v raised to minus 1 minus 1. And dv by dt we know it is acceleration. So that is equal to d by dt of 2x. So 2 is a common, we will take it out. So 2 times of dx by dt plus 0 because the differentiation of constant number is 0. So left side again we will continue. So minus 1 by v raised to 2 into acceleration is equal to 2 times of v. Dx by dt is v. So acceleration is equal to, now I am taking this minus sign to the right side. It will become minus 2v, and this v square I am also taking it to the right side. So this is v square. So acceleration is equal to minus 2v cube. Similar question was asked in NEET 2025, and in JEE main also previously this type of question already asked in previous JEE main examination. Next we will discuss about graph. And what do you mean by slope? What is a graph and what is a slope? So in mathematics, the graph is defined as how to represent relation between two quantities using pen and paper, using a diagram. So we have to consider one vertical axis and one horizontal axis, because at a time we can compare only two quantities. If more quantities are there, but at a time only two quantities we can compare. So one quantity, the variation means change. The quantity may be increasing or decreasing. So the common word for change is increasing or decreasing is change or variation. So in horizontal line we will consider one quantity, in vertical line we will consider one quantity. So point of intersection is called as origin. So 0, 0. Now in motion we have quantities as position x in motion along straight line, position x, velocity v, acceleration a, and time t. So these quantities we have. So we can consider position x changing with time t, we can consider velocity v changing with time t, acceleration a changing with time t, or position changing with velocity, position changing with acceleration, or acceleration changing with position, acceleration changing with velocity, or we can consider acceleration changing with time. So any two we can pick. So in general, so let us discuss general concept, then we will solve some questions related to position, velocity, acceleration and time. So y-axis we are considering quantity y, x-axis we are considering quantity x. Now here x is not position, it is a general quantity. We can consider a, b also. So we are considering y and x because normally we are familiar with y-axis and x-axis. So y and x are two quantities. Y and x are two quantities. So suppose this is the origin. If x is taking positive values, so we have to move on the right side of origin, and if x is taking negative values, so we have to move on the left side of origin. Similarly, if y is taking positive values, we have to move upward along y-axis, and if it is taking negative values, we have to move downward along negative y-axis. So graph, what is a graph? So we have a paper and a pen. So how to plot a graph? Suppose I am saying when x is equal to 1, y is equal to 1. The information is given to us. So when x is equal to 1, the y is equal to 1. Then we will draw one horizontal line passing through y is equal to 1 and one vertical line passing through x is equal to 1. And we will see where they are meeting. So that point we will consider as a 1 comma 1. So we call it coordinates. We call it coordinates. Coordinates means the value of x and y together. And suppose we are given x is equal to 3 when y is equal to 2. So we will consider the point x. So this is x equal to 1, then this is 2, so 3. So 3 will be somewhere here. So x is equal to 3 is here, then the y is equal to 1, then y is equal to 2. So approximately we can say the y is equal to 2 is here. We will draw one horizontal line passing through y is equal to 2 and one vertical line passing through x is equal to 3. So we will see where they are intersecting. So this is another point we got. We can call it 3 comma 2. This point is 3 comma 2. So we consider all these type of information, more values of x and more values of y. So we will plot it. We will plot it means we will mark these points. These type of points we will mark, and we will join these points using smooth line or curve. Smooth line or curve. A smooth line can be like this, or smooth curve can be like this or like this. So that shape we get when you join all these points is known as graph. So basically we have two important graphs to learn. First we will master the concept of these two graphs, that is known as straight line graph, straight line graph, and second is known as parabola. First we will talk about these two type of graphs, then we will discuss about slope. First we will see how these graphs look. So suppose this is the y-axis and this is the x-axis. If graph is like this or graph is like this, it is a straight line graph. Sometimes the graph can be on the negative side. Now over here you see the y is positive but x is negative. Sometimes both are negative, so graph will be like this. When x is negative, y is also negative. Suppose negative and positive both are considered. When x is positive, y is a positive. When x is negative, y is also negative. So graph will look like this. It is a straight line graph. The graph can be like this. This is vertical line, horizontal line. The graph can be parallel to x axis. The graph can be parallel to y axis. So these all are examples of straight line graph. How parabola graph look like? This is y-axis, this is x-axis. So it is like a bowl. Like suppose when we eat rice in a bowl, the bowl is of this shape. The base is flat. The base is flat. And it opens like this. It opens like this. So if we ignore this flat surface and imagine the ball is looking like this with pointed flat region, the flat region is now a point. It is not a significant flat region. It is just a point. Now this bowl, it is a bowl is opening upward. So this is one type of parabola. The shape of the parabola, it can be opening downward like this. It can be opening downward like this. It can be opening right side. It can be opening right side. It is opening right side. It can open left side like this. So these are the four types of parabola. If you observe, this parabola is opening upward, or we can say positive y direction, and this parabola is opening downward, which is a negative y direction. This parabola is opening rightward, which is a positive x direction, and this parabola is opening leftward, which is negative x direction. So these are the four types of parabola. We will discuss this parabola also in detail. So let's start straight line. First we will discuss straight line graph. When two quantities y and x are related as y is equal to mx plus c, the graph will be straight line. The graph will be straight line. What is m here? M is called as slope or tan theta. Other word for slope is gradient. And what is c here? C is y intercept. C is y intercept. Let's discuss what is the meaning of slope and what is the meaning of y intercept. So let's consider some straight lines first. This is y axis, this is x axis. Suppose this is the straight line. So this straight line is passing through origin. The value of x is 0, value of y is also 0. So what is the value of y when it is cutting y axis? What is the value of y? It is 0. So y intercept is 0. Y intercept is 0. You look where the straight line is meeting y axis. Y axis, and this is the point of meeting or point of intersection where straight line meets y-axis. So it is meeting y-axis at origin, which is x equal to 0 and y is equal to 0. So the y-intercept is 0. So the equation of straight line will be y is equal to mx plus c, and c is 0. So y is equal to mx. Now, how to find m? For that, you have to consider angle made by straight line with positive x direction when measured anti-clockwise. Angle theta is angle made by straight line measured anti-clockwise with positive x direction. So we have positive x direction, this is the positive x direction, and angle theta is measured anti-clockwise. Then we find tan theta, that is known as slope or gradient. Then quickly I am writing the values of tan theta. So when theta is 0, 0 degree, tan theta is 0. When it is 30 degree, tan theta is 1 by root 3. When it is 37 degree, tan theta is 3 by 4. When it is 45 degree, tan theta is 1. And when it is 53 degree, tan theta is 4 by 3. And similarly, few more angles. When theta is 60 degree, so tan theta is root 3, and when it is 90 degree, so tan theta is 1 by 0, 1 by 0, or we can say it is infinity. It is infinity, or we can also call it not defined. It is a very large number. It is a very large number. It is very large number. We cannot know what is that large number. So that's why we call it not defined. In mathematics, we call it not defined. So suppose the straight line is making 30 degree. So the slope will be, if the straight line is making 30 degree like this, so slope will be tan 30. So tan 30 is equal to 1 by root 3. If a straight line is making 60 degree, so slope will be tan 60, so that is root 3. Now in these both examples, the line is passing through origin, so the value of c will be 0. So the equation for this line will be y is equal to m. Now m value is 1 by root 3, so mx plus c is 0. So y is equal to 1 by root 3 into x. This is the equation of a straight line. And for this one, we have y is equal to m, which is root 3 x plus c. C is 0. So y is equal to root 3x. Suppose the straight line is making 45 degree with x-axis, and it is passing through origin. So we will say the m is equal to tan 45, which is 1. So m will be 1. So 1 into x. C is 0. So y is equal to x. This is the equation of straight line. Let's consider c is equal to 2. So the straight line will look like this. At what point the straight line is meeting y-axis? So at that point y is equal to 2, and we can also say the distance of that point is 2. This distance is 2. This distance is 2. And suppose the angle made with x-axis is say 37 degree. So we can say the slope is equal to tan 37, which is equal to 3 by 4. Slope is equal to 3 by 4. So the equation of a straight line is y is equal to mx plus c. So y is equal to 3 by 4x plus c, which is 2. So this is our straight line and the equation of straight line. Let's consider some other type of straight lines. You have y-axis, you have x-axis. What if the straight line is like this? In this type of straight lines, if you observe, the angle made from positive x direction is more than 90. This theta is greater than 90 degree. You can call it obtuse angle also. So how to find tan theta? How to find tan theta when theta is more than 90? So suppose theta is equal to 90 plus alpha. So we have tan 90 plus alpha is equal to tan theta, and tan 90 plus alpha. How to find tan 90 plus alpha? We know that sin 90 plus alpha is cos alpha, and cos 90 plus alpha is minus sin alpha. So tan 90 plus alpha is sin 90 plus alpha divided by cos 90 plus alpha. So sin 90 plus alpha by cos 90 plus alpha will be tan 90 plus alpha, and sin 90 plus alpha is cos alpha, and cos 90 plus alpha is minus sin alpha. It will be equal to minus cot alpha, minus cot alpha. So suppose if you draw one vertical line at a point on x-axis where the straight line is meeting x-axis at this point, so this angle will be alpha. So suppose let's consider one straight line. This is the straight line. Now this angle is given as 120 degree. So we will draw one vertical line passing through this point. So this angle will be alpha. Now alpha will be 30 degree because 120 is 90 plus 30. So the slope in this case, slope will be m, which is tan 120, and tan 120 will be tan 90 plus 30, and tan 90 plus 30 will be minus cot 30, and minus cot 30 will be minus 1 by tan 30. So that is equal to minus 1 by root 3. So that is equal to minus root 3. The slope of this straight line is minus root 3. One more method is there. If the same situation is there, but we can solve it using different methods. Suppose this is theta. You consider this angle. Suppose this angle is alpha. Remaining angle. This total angle is 180. 180. Up to here it is theta. Remaining is alpha. So alpha plus theta is equal to 180. So we can say theta is equal to 180 minus alpha. So in this case, slope is equal to tan theta, which is equal to tan 180 minus alpha, and tan 180 minus alpha is equal to minus tan alpha. Let's take one example. Suppose this is the straight line and this angle is given as 120 degree, so this angle will be 60 degree. So over here alpha is 60 degree, so slope will be m, so which is equal to tan 120 degree. Tan 120 degree can be written as tan 180 minus 60. So tan 180 minus 60 will be called as minus tan 60, and tan 60 is root 3, so minus tan 60 means minus root 3. So this is another method. So it depends on you as a student which method you want to follow. You want to follow the previous method or this method. So I prefer this method. So suppose the straight line is given as, this is the straight line and these 2 points are given. So for this point the value of y is 0 and x value is given as 5. So this is 5 comma 0, and this point is for this point x is equal to 0 and y will be positive. So suppose this is 0 comma 3. Now how to find the equation? So we will see the c value. The c value is 3. From origin you have to go 3 distance to reach this point. So this is known as y-intercept. So the value of y-intercept is equal to 3. Now we will calculate this angle alpha, basically tan alpha. So tan alpha is equal to opposite by adjacent, opposite by adjacent. So this is opposite. Opposite is 3, adjacent is 5. So tan alpha is equal to 3 by 5, but we have to find slope. So slope is not tan alpha, slope is tan theta. So slope is tan theta. So slope is equal to tan theta is equal to, now we know that theta is equal to 180 minus alpha. So it will be tan 180 minus alpha. So that will be minus tan alpha, and tan alpha is 3 by 5. So minus tan alpha will be minus 3 by 5. So we got the slope. Now we will use the equation of motion, which is y is equal to mx plus c. Now we got the slope, which is minus 3 by 5. We got the intercept on y-axis as 3. So we will substitute here. So y is equal to minus 3 by 5x plus 3. So this is the equation of straight line. Now let's make one table. In physics, specifically in a motion in 1D. Motion in one dimension, we have few quantities. So let's take two quantities at a time. So suppose we are taking xt, position x and time t. So the slope will be velocity, because the meaning of slope is dx by dt. When we have vt graph, so this is velocity time graph, so the slope will be dv by dt, so that is acceleration. Slope of vt graph is acceleration. So these terms we have to remember. If velocity time graph is given, slope is acceleration. If position time is given, the slope is velocity. So let's do some question. Let's understand one situation using xt graph along y direction, that is vertical axis, we have plotted position x, along horizontal line we are plotting time. So when time is 0, the position x is also 0. And suppose the graph is like this, it is a straight line graph. It is given in question when time is 3 seconds, the position x is 4 meter. How to find velocity? So it is a straight line graph. So in a straight line graph, we have to remember the slope is constant. Slope of straight line graph is constant. It is constant. So it is a xt graph, position time graph. It is a straight line. So velocity is constant. First of all, how to calculate velocity? Tan theta. Tan theta is the slope. So we will find this angle theta and tan theta. So opposite is 4 and adjacent is 3. So slope is equal to 4 by 3 and slope is velocity. When xt graph is given, the slope is velocity. So velocity is 4 by 3 meter per second. Let's take one more example. Suppose this is y-axis, this is x-axis, this is the graph. Over here, the coordinates are given as 0, 5. And here the coordinates are given as 3, 0. And this is origin, we know that it is 0, 0. So horizontal axis is time axis and vertical axis is position x. What is the velocity? Find velocity. So we know that the velocity is the slope. Velocity is the slope, and by looking at the shape of this graph, we can say the slope is negative because the angle theta is more than 90. So slope is negative. So let's calculate tan alpha. So we will have tan theta is equal to minus of tan alpha. Now tan alpha will be equal to opposite by adjacent. Tan alpha is equal to opposite by adjacent. So opposite is equal to 5. Adjacent is equal to 3. So that is 5 by 3. So we have tan theta is equal to minus 5 by 3. That is the slope. So the velocity is minus 5 by 3 meter per second. Let's take one example of AT graph. When AT graph is there, the slope will be velocity. If it is a straight line, the slope is constant. So vertical line we are considering acceleration and horizontal line we are considering time. And let's consider the straight line like this. Now for this point, let's consider it is a 3 second, 0 meter per second square, and this point as minus 4 meter per second square, comma 0. The acceleration is in meter per second square and time is in second. So what is the slope? So AT graph, the slope is dA by dt. Wait, we have to consider VT graph.